morning, everyone. My name is Jack Nyman, and I'm the Executive Director of the Stephen L. Newman Real Estate Institute here at Baruch College, City University of New York, sponsor of today's conference, Building Information Modeling. Buildings breathe. They are conceived, they are born, and whether or not we witness it in our lifetime, they eventually turn to dust. These structures are made of a complicated systems biology. Beginning with the planning of a structure, buildings take on a life and a personality all their own, from conception, financing, and construction to the nurturing aspects of maintenance. They may continue to live through one or several renovations or succumb to the natural course of age and neglect. How do we map this unique biology from its genetic code to the way it coexists with its immediate environment? If one gathers all the data on how a building is designed and functions, can that inform the way we give a building meaning and life? Today, we will discuss how building information modeling, or BIM as it's commonly referred to, is an evolving revolution in facility and building management. It's potentially an invaluable tool that maps the processes that create and deliver properties. By combining data collected from exhaustive sources on each individual project, including architectural, engineering, financial, legal, construction, trades, and subtrades, BIM introduces a creative cohesion of complex variables that helps to maximize the return on investment for any given project. First created in the 1970s, BIM is a process that involves the generation and management of digital representations of the physical and functional characteristics of a building. So what does this mean? Brick by digital brick, BIM coordinates data input into a visual output, creating a map of the building. By identifying weaknesses and problems such as clash detection, BIM is an important resource that can form a reliable basis for critical decisions about a property. This provides numerous opportunities to optimize the construction and enhance the functionality and performance of a given building. It creates a natural tool for monitoring the green record of a property and helps to optimize its energy performance. Today we'll hear some of the challenges of incorporating BIM into practical applications. In its own 40-year lifespan, BIM has undergone many developmental changes. Our speakers today will help us understand how they use this modeling tool and share what their own experiences have been.
We have taken the department in a much bigger direction. A year ago, we created the New York City Development Hub. We accept digital plans in 2D. I have the great fortune of dealing with every architect and engineer in New York City, not just a select few. And they all have a different perspective of the way the world should work. But moving them to adopt a digital model takes time. And you or I as the city agency have to encourage them to do that. We actually now accept digital plans. We use web conferencing. We use very simple tools. No big, you don't have to buy Navilis or anything. All you have to do is have Adobe Acrobat, a webcam, internet, and we can see you and talk to you, draw on your drawings, and you never have to come to the department. Many architects and engineers actually already design like this in the world. So for the big guys, this was not news. They've been doing it for like 5 or 10 years already. They're developing buildings in China. They have star architects from Europe, and they're all doing it this way. But our challenge is to get everyone else on board. We've actually been able to realize it to be done 3 times as fast. We've already done over 300 big projects in New York City, and this is the wave of the future in 2D. You're already in 3D, and we're going to get there. The second thing we've done is now the smallest projects, you never have to come to the department, and we just launched that about 8-10 weeks ago. The idea here is that we are moving completely digital, but there's a tremendous amount of collaboration that it affords us to do, just like BIM does, and you've been able to see it. We started to accept BIM models for safety. It has to do with the logistics on a job site that change every day. It has to do with making sure that workers and pedestrians and the public are safe. It has to do with big pieces of equipment moving, as some people talk about, creating this orchestra and this ballet in the sky of moving huge tons of material, placing them exactly so, and making sure they all fit together. And so what we require, we pretty much think we're the only city in the world that requires you to file a separate set of plans just for the logistics of how you're going to do the construction, the actual day-to-day construction. And this is what sometimes we see. It's a 2D drawing that shows us the cranes, it shows us the excavation site, it shows us the particulars of the way it's laid out, the pick zone, the fence, how you're going to protect the public, the sheds, you know, the sheds that you walk under. All of those things are there to protect the public. How do they all work together? It's a huge coordination nightmare. Companies, major companies in New York City, Tishman, Turner, Bovis, you guys know all their names, they know how to do this, and they use drawings to do it. But when you do it on a 2D, this is what it looks like. In 3D, this is what it looks like. And all of a sudden, all of you, I love to come to these things because I'm preaching to the choir. You already know the benefits of showing a design in 3D. You can show your client, people can walk through. But when you think about it, when you're talking about these dynamic changes on the job site, it's a huge opportunity and a huge win for construction safety. So we said, well, you know, if you build it, they will come. So we tried it. So we worked on our first project with Turner at 433 Lexington Avenue. And they came up with the 2D, and then they basically already have done it for all their clash detection. They already built the model. All we asked them to do is layer on the stuff that we care about. And it's not that much more. And they did that. And 3D was born. We sort of collaborated with them, we figured it out, and now we've accepted already 13 projects this way. You want to make a change in the street, you update the file, you let us know, and we can see it. This is what the 3D model looks like, and this is what it really looks like. So in the field, you transfer it out of the office, and in the field, all of a sudden, you give one of our inspectors or an engineer an iPad or a tablet. He can go from this to that. And it already becomes really clear. He can click on certain items. It gives them lots of detail. And already, you can see the huge benefit that this provides. So last year, Construction Safety Week, we announced it. This year, we're going to be working through what we've been able to find out in this past year. We have 7 more projects that have filed this way. It's a tremendous opportunity. These are the active BIM projects that we have already approved and the ones that are active. This is our universe of what we call major site safety jobs. These are the largest jobs or the most complicated jobs that affect the public. And these are the ones that we are focused on and talking to the major developers, the site safety professionals. We are moving them here. Okay, and when I say moving, you know exactly what I'm talking about. There are many times where you're sitting in a room and nobody wants to do it. So you have to stay focused and push. And what I would suggest is that if no one's listening, then your messaging is wrong. You've got to start smaller, you got to start simpler, and you have to talk their language. Who is the decision maker really? And why don't they want to make the decision to do it? You have to figure that out. So in order to begin this process, we made it very simple. It's on the web, on the front page. You click through. We have a guy in charge. This guy, Chris Santulli, and our real BIM manager who's sitting over here, Mr. Singh, is he's going to be here all day today. He has been the one working on it. The next step is now to figure out a way for it to start to be done automatically. So today we're just doing it as, again, I'm saying do it in steps. You figure it out, you see how it works, you get people to adopt it, you got to train the guys to actually use it in the field, and that's what we're going to be working on this year. The next thing is that you have to figure out a way to get it to start to do the auto checking for yourself. Because all of a sudden, if you can imagine what we do 20,000 permits a year. We're a factory. We have to process things quickly. BIM has tremendous opportunities for us for code checking. But we have to get there. We have to have standards. There's interoperability issues. I mean, you know, the list goes on and on. All of you know that. So what I'm hoping happens today is when you walk out of here, you probably take something away and you go back and maybe even say to the person that you're working with, well, so-and-so's doing it, and why aren't we? And maybe that's just enough reason to push them over the edge. But the other thing is that you might be able to figure out a way to sell it. And I think that's what's really important. So when we went to doing the digital hub, the 2D model, there's a lot of interests there. There's the owner, there's the architect engineer, there's the filing representative, and all of them have to come together and agree to play differently and change their process. So a lot of things you're going to be talking about today, right? Subcontractors don't want to have to be on the same platform as the prime. But all of a sudden, when you do that, there's a whole bunch of information that starts to become available to all the parties on the chain. And like I said earlier, all of a sudden, competitive advantages change, concerns about proprietization change, ways of doing business change, legal issues change. All of those things start to stand in your way to implement. But you all know that it's a better way to build, it's a better way to keep track, it's a more efficient way to do it.
Smart development creates thousands of good jobs for so many of New Yorkers, so many of us New Yorkers. It is imperative that we continue to learn about utilizing 21st century technology and to become more efficient and safer in our building process. And that is what BIM can do. You've already heard from the Buildings Commissioner about how the city is beginning to implement BIM to review safety plans, but there's nothing more important than for workers to work in a safe environment. There is an even greater use for BIM in terms of public safety. And on the City Council, I chair the Committee on Fire and Criminal Justice. And during an oversight hearing we had last year that examined the fire department's terrorism and disaster preparedness plan, the department discussed a program that they are using with electronic command boards, known as ECBs. These ECBs are wireless devices that a battalion chief or an incident commander can use at the scene of a fire to review architectural plans and blueprints of buildings. This information is transmitted by the fire department's operations center. ECBs also allow incident commanders to track where individual fire units are currently, where they're located, and direct firefighters to where they are most needed. The enhanced and growing use of BIM can revolutionize this process. With BIM, firefighters can know exactly what awaits them as they rush into a burning building. Incident commanders can have information about fire ratings of materials within the building, information about the nearest fire hydrants, standpipes, and a wealth of other information. The ability to map out various scenarios using BIM can also be a critical training tool for the city's first responders. BIM can teach firefighters how a fire might spread in different building conditions and help them create a plan to best extinguish the blaze. It can help them visualize best methods that to help people evacuate. And it can also be used by the Office of Emergency Management and the New York City Police Department in crisis situations. So I'm so excited, and I'm interested also in seeing how BIM could be used in the construction industry to increase efficiency, transparency, and reliability. This past year, actually a little over a year ago, in 2011, the City Council passed a bill that would require the Department of Housing and Preservation to report certain statistics for affordable housing projects. The city claimed that this would place an undue burden on the HPD, on the Housing Preservation Development Agency, and the bill was vetoed by the mayor. The City Council overrode that veto because we believed it was important for construction projects that were receiving tax dollars to be more transparent, and for the developers and the contractors that were awarded these contracts, that they could report to the city who was working on the projects and exactly how much they were getting paid. This law now requires all contractors and subcontractors with an annual gross revenue of at least $2.5 million of project contracts with the city to report the wages paid to laborers on city-funded affordable housing projects. The reporting requirement is designed to prevent contractors from misclassifying workers in order to underpay them, which unfortunately has happened, failing to pay workers for all hours worked, and falsifying payroll documentations. I envision that a BIM model could be designed to include wage records that contain all information needed to comply with this law, and the wage reports could be generated with ease on a weekly or even a daily basis. Like I said, the city has claimed that it was too expensive and too much administrative work, but we all know that the use of BIM can be streamlined in this process. Contractors are already beginning to use BIM to eliminate overall costs, including the amounts of hours their laborers are working. Contractors gladly do this because it allows them to save costs by eliminating redundancies. This can easily be translated to the reporting of how the HPD is now required to report. So I'm eager to see BIM incorporated into more government projects in the years ahead of us. To me, BIM represents a modern version of the old adage, measure twice, cut once. Building virtually, owners, architects, and contractors have the opportunity to spot construction issues and to resolve them before a lot of time, money, and resources are expended. Fewer change orders leads to cost savings and timely completion of projects. Fewer changes also means that there's less critical time wasted, which improves the environmental footprint on a particular job. Additionally, BIM data has the potential to be useful in emergency response situations, which I believe is so important in the state of the city we live in today.
Now, we're drywall subcontractors. So why are we here as a drywall subcontractor? Why have we helped produce, and here I'm not going to go through all of the specifics, but you know, in our society, if you're a disaffected group or not recognized or a minority group in whatever endeavors you have, you want to get into the mix. You want to be recognized as part of the solution. And right now, BIM does not include the wall and ceiling contractor. So John Lord and I, we joined the International Alliance for Interoperability back in '96, believe it or not. And we're here today in 2013 to say, let's get this going. Back then, I have an article which said, why are we creating this International Alliance for Interoperability? And Bob, again, you mentioned that, which really have a good handle on it. And it says we want to have information accessible in a common language at each stage of a building project that will enable each subsequent phase to build on previous information created for the project. So, common language. Is that something we know in the construction industry? Do we talk a common language? As subcontractors, all the risk is passed to us pretty much, and we provide the labor and materials. So we've got to step up. So the idea was that the software users would be able to select the most appropriate package, knowing it will interoperate with existing software used by other disciplines in the stages of building, development, construction, and now facilities management. Unfortunately, that hasn't really taken place. Part of it was technological, that they weren't ready. But mostly was the people and the way we run our construction projects. And today, as we do perform many large projects in New York and around the country, because we have offices in different cities, we're seeing so many different types of BIM. There's not one flavor of BIM. It's a process. It's not just a nice picture. So we want to move the industry forward, to be more transparent, and to differentiate our services, and not just be a number on a page when they buy drywall. Who are we? What do we do? Have we kept the job on schedule? Are we a reliable partner in the process? And one of the big things now in New York is growing the high-wage labor sector from the contractor side to show that we are worth double of what Open Shop is right now offering to New York City. And you know that New York City is now an open market for union and non-union work. So basically, what we have to do is get the contractors on board, and this really involves the subcontractors. We have to create best practices, and we've heard in the industry a low price buys a lot of aspirin. So if one of our competitors submit a price $2 million under us, well, it'll buy a lot of aspirin. Problem is, there's been a lot of headaches in our industry, and there's probably not enough aspirin to go around. Okay, so what is the risk and reward? How are we as GCs, subs, can we work together to provide the services that will make us all grow the industry, not be worried about where we're going? What I'm proposing here is from this ABA, the American Bar Association, and I am an attorney, we're going from that ABA, the litigators have basically come in the middle of our construction industry. And they don't want to stop that because this is their business, right? So I want to get that ABA out of our industry, and I want this ABA in as-built actuals. What are we doing? What did we really build? Forget about a model. That's what we plan to build. So with LiDAR, which is light detection ranging systems, plus the correct data, we can tie it together. And I would recommend that you go to the Building Smart website to see how information exchanges are going to work in open, and the Army Corps is working on this now. So what are we looking at? This is one of the agencies. I'm not going to mention names of agencies. This is how subcontractors currently report data. Okay, payroll data. Okay, you can see it lined up. How many people? All handwritten. Issues. Okay, codes, all handwritten, not retyped in. Where are we on the job? What are our tasks? This should be electronically reported. As Elizabeth mentioned, this is what's going to drive transparency. Owners, lenders, I've seen a lot of owners are here today, and lenders, big universities. Without the government requirements to make this electronic, BIM becomes a design tool and then a facilities management tool. You miss the whole construction process. And unfortunately, we're on a lot of large projects. We don't see real scheduling on our projects. Dynamic, real-time scheduling. Because you know why? There's no data. There's no data that applies to the model, the schedule, and what we've installed. There is the Governor Cuomo's budget that within there, snuck in there, there's a piece that says the design build now is going to apply to vertical buildings, not just the Tappan Zee Bridge, et cetera. That's huge. But part of the way they decide who's going to get the contract is that authorized state entities shall evaluate and rate all entities responding to the request for qualifications, including on project understanding, financial capability, and the record of past performance. How are they going to come up with these criteria if there's none of this data and management, especially of subcontractors? We perform the labor. We know what's going on, and the subs have to step up to this challenge, and that's where Commissioner Lamandry, again, maybe we should have a conference with the subcontractors, seriously, where we can talk from buildings to subs and get them to realize, stop hiding things, because you're right, we hide, and that's not going to work anymore in New York City. We've got to be the leaders.
The basis of BIM at New York City Transit, I felt could be kind of coined in this paragraph from our specification, our BIM specification, I should say. So any projects that are going out right now from New York City Transit have a specification, BIM specification. This is it. BIM implementation is both a practice and a project delivery-based effort. Thus, it impacts all levels of the organization, and each group shares a portion of the responsibilities for effective BIM use. And this has already been mentioned by a number of our speakers this morning. Practically in our organization, however, if you look at these bullets, BIM is managed during design based on these procedural requirements. So kind of quickly, for every project we have a strategic session. And what do we do at the strategy session? We determine whether we're a BIM go or a no-go. And if we are a go, what does that mean? John earlier was saying there are many flavors of BIM. That was a kind of fun way to put it. The real thing is that BIM isn't always applied to every job the same way. And so during that strategy session, we're making those decisions. Once that's decided, implementation plan comes into play. There's a group of people, the design manager, it's their responsibility to make sure that it's put together properly. And that's where all of the definitions of how the project in design is going to follow. We then have workshops to get the project started, and then regular coordination meetings, no surprise, like any other project. And then at the end of the job, real critical is lessons learned, not just lessons learned on the design project, but really lessons learned on how we've applied BIM so that on the next project we can do it better. I was asked to show examples of how we're using LiDAR at New York City Transit. We don't use LiDAR at New York City Transit. We do, however, use laser scanning to do some of our surveys. These are a couple of images from taken when we surveyed the Vanderbilt Tunnel, which is a tunnel actually not in use, where we're designing a circuit breaker house right now. Point cloud data is then taken and vectorized, it's translated, and then a BIM is created from the point cloud data. The first BIM project that we did at New York City Transit, I thought I'd introduce you to, just to give you a flavor of what we're doing here. So we've got a couple of slides. This is the 10th Street substation. As you can see from the bullets during design, it was a successful project. And now with a little luck, John over there is going to hit a button, and you'll see this is just talk about point cloud data. This is the survey that was done. It was an existing substation, which we were gutting, renovating, and adding to. So just you know, all of that, getting all of that information in, which was very helpful for the design. Let's see, we can move on. Together, the design disciplines created a fully integrated BIM, which was shared with the GC, as Erlene mentioned in their PNC project as well. Presently, we're in closeout on this job, and the GC is required to deliver an as-built BIM to us with the potential use, and I say potential use for operations. I doubt that on this project, as it was our first BIM, that we're going to be too successful at getting the operating side of the house to embrace. They're on board. They think it's great. They understand the great advantages of having it, but we're a huge organization, as you well know, and in terms of operational procedures, to you know, turn that ship is a big turn. So the discussions are happening. I have to say that our buses department is moving a lot quicker in terms of embracing BIM for operations. Not in this presentation, but you may well know we have a design build project going on in northern Manhattan, a bus depot, and they're very excited in anticipation of that coming online so that they can use it for asset management. This slide maybe will also go into a video, but you know, when BIM first came to New York City Transit, when it was first envisioned, the thought was, and the thinking probably still is, that it would be great to have all of the system modeled so that we could use it as an asset management tool. It's a daunting task. It will be many, many years before the whole of the system is modeled, but most certainly it's a vision that we're going there. This, by the way, is 23rd Street. I just thought it was apropos since we're here. And this is an ADA project. We have more and more, as you know, projects that we're making our stations accessible to the handicapped, and so this is going to be one of those projects. We've been successful using laser scanning. This is just a couple of images where that laser scanning was used at the Joralemon tube, not just as a survey tool, but also, as I think Orleen mentioned as well, it was used for fabrication as well. The steel plates that were used for shielding there, within a 1/16 of an inch of the original BIM design, and so this notion that, I assume that we'll hear from the lawyers later, but if anything, it's giving us a much greater detail and less risk in terms of sharing data. So our recent projects, we've been now using BIM to do design review. So as I say, there's a way in the organization to try and get the operations side to embrace BIM. The first step in that is to take the BIM, and when they're reviewing our documents, they're now using the BIM. We're starting now. We have 2 projects out there where we're not giving them any paper documents to review. They're using an iModel. Those who are not, say, CAD or BIM savvy, it's easy for them to navigate through it. They get all the detail, measurements. They can click on any element. They know all of the information about it. There's actually more data in there for them to be reviewing. So very exciting. They're really looking forward to that process.
So why BIM? We recognize the overall quality and productivity enhancements with the use of BIM and documentation improvements as well, which helps DDC deliver on its mission of design excellence. All right, so one key aspect of BIM was the use of building information modeling to augment DDC's building assessment data, in which we're looking to have an expanded resource for the use of the information. Many of our projects are existing projects. We don't do too much new construction. So the majority of our portfolio is existing buildings, and we're looking to capture that information and use it for future projects when we have to revisit projects over and over and over again in the same building or same location. There's the 3D and 4D for visualization and logistics, as well as getting into a little bit with 5D cost. So give us BIM. We got started with the use of BIM back in 2006, 2005, 2006 on some of our much larger projects. And early on, it was the consultant will be required to use a building information modeling program, Revit or similar. And that's what was in the contract. And in 2006, that wasn't enough. And today, that's still not enough. We need to get more specific with regards to the planning and implementation of BIM on our projects. We got a little better at this. We said the consultants will be required to use building information modeling software to coordinate and track, et cetera. And we specified the National Institute of Building Sciences standards. But yet still, it's just not enough. When you include language like this in your contract, you need to be a little bit more specific with regards to your objectives, what it is you're looking for, and what you're looking them to achieve on a particular project. So if we fast forward to 2012, July 2012, we released the DDC's BIM guidelines. It provides guidelines for the consistent development and use of BIM. The BIM guide considers the end use of the model for multiple client agencies. The intent is to improve the design, management, and construction of our projects. And also included in the DDC BIM guides, within 30 days of a project being awarded, we do require a DDC BIM execution plan, which is very important for implementing BIM on our projects. I'm going to get into a case study for the New York City Police Academy. Some of the key strategies was implementing BIM, the active design guidelines, and really taking a more team-based, lean-oriented approach to the design and construction of this particular project. The project's located out in College Point, Queens. It is a campus. This is the site of the project, located on an old NYPD tow pound lot. Here are some renderings of the project when it will be completed this year. The project was designed by Perkins & Will and their sub-consulting consulting engineers. The project was designed in a co-located office. So to the extent that we're afforded certain contractual obligations within state law, I think an integrated project delivery would have been ideal on this project, but we're not able to enter into those forms of agreements based on state law. So what we were able to achieve was an integrated office and have the team co-located, which helped foster collaboration on a project. So we had the entire design team in the same location using a building information modeling application to design this project. Also located at this co-located facility was the owner, which was DDC, and end users, which would be the police academy, the police department. So all of the major players were there. You had the key decision makers available to answer questions, and all the design work was done in this integrated office using a collaborative tool, collaborative BIM application. Some of the key aspects of BIM: visualization, design coordination, clash detection, both during design as well as in construction, scope delineation during the construction of the project, as well as targeted quantity takeoffs during construction.
For us, it's more than just another just another tool in the designer's toolbox. It is a way of working that enables a more efficient design process, enhances communication, promotes a collaboration that we had not really seen before at a high level between the client, the architect, the consultants, the GC, the vendors, and can lead to a much better, tighter final product, and ultimately has a life beyond the design and construction process. I wanted to briefly touch on 4 case studies, and I'll do 2 domestic and 2 international, since a lot of my practice is globe hopping. The first one illustrates our early adoption of BIM. It's an existing tower called 1 Indiana Square, and it suffered significant skin damage. This is the before shot. During a large storm that hit the city. And the task was to replace the entire skin while the building remains about 100% occupied. And how do you use technology to do that in a way that you can simulate the entire process before you even put one worker out there on the site? So for us, this early adoption of BIM technology was able to really simulate construction and coordinate with a structural engineer. And actually, these series of thumbnails show some of the step-by-step process that we were using before we did any work on site to show how you could place the new skin atop the old. And actually, that's what we ended up doing, is literally layering a whole new skin on top of the old and then surgically pulling out the old skin of the building internally out in the evenings when people weren't working. Doing so allowed the curtain wall fabricator to visualize their scope of work, for us to have the numbers down to a tolerance level that was extremely realizable. The before shot is on the left. This is a computer model on the right. The computer model, as most of you are experiencing, is really just the rendering is a byproduct of the design process. And that's one of the things that makes BIM so great, is that you're working in 3D, so being able to kick out a rendering is relatively easy. This is the after shot, if you can see that, of the building. And this is some zoomed in shots of that skin. So traveling 8,000 miles away to Shanghai, we have a project that's under construction right now, which is a really exciting opportunity. It's called the Shanghai Tower. It's on the banks of the Pudong area of Shanghai, which is kind of skyscraper city. When complete, in not too far of a timeline, it will be the second tallest building of the world, in the world. It will be the most advanced super tower in the world. It is 121 stories. It's 632 meters tall. For those doing the conversion, just multiply by 3.3 and you get the feet. And it was using BIM technology the whole way to study the building design and the building performance and coordinate and communicate with all consultants involved in the process. So these renderings, and hopefully give you a sense of scale, and obviously I threw in a New York landmark at the bottom right just to get a sense of scale comparison. The existing two buildings that are to the left of the tower are built, and they're much more conventional skyscraper construction. One of the things for us is we recognized that using BIM technology, we were able to start to simulate and study things earlier in the design process that ultimately led to a transformed tower. One of those was understanding that by twisting the tower, we were able to reduce the wind load on the building and therefore reduce the structure by 20% in the building. So by rotating it roughly about 120 degrees, we were able to kind of have that structural enhancement to the building. But not only that, it creates a transformed architecture. So the architecture vocabulary changes vis-a-vis the design process with BIM technology in there. And then we tested that out in a wind tunnel and found out that that is indeed true, and then started to use the technology in actually a mixture of programs and then some unique interfaces between those programs, between Revit, between Grasshopper and Rhino and AutoCAD, et cetera, all in concert with each other to really pull out the floor plate, because every floor plate was different. And understand what we are getting in terms of a building. The interesting thing about the Shanghai Tower is that it actually uses two skins in a very different way, and the model on the left really demonstrates that. So the skin on the left is the outer skin. The diagram in the middle of the three-part is showing the structure that supports that outer skin that is really floating away from the building. And that inner skin is then hugging the floor plates and the core, and everything is held up over an 8-zone stacking by a series of outrigger trusses, then creating that interstitial space which actually acts as an atrium vertically on the model. Sticking on that side of the country, or the side of the globe, is Duke Quinshan University, which is a project I've been heavily involved in. And this is right outside of Shanghai, and this is the first full campus being built all at once for a top-tier American university abroad, working with multiple partners throughout the design process and using BIM technology as a way to kind of get over the language barrier that is intrinsically involved in international work. So the first phase of this is well under construction now. It's 40 acres, 750,000 square feet spread out over 6 buildings. And one of the amazing things about this is that for us, we were given basically a 3-month window to design and document all these buildings inside and out using BIM technology. And what we found is that with the technology and a savvy team, we were able to do all this, deliver on time, under budget in terms of the work that we were doing, and being able to do it with a team that was a fraction of the size that we would normally use on such a significant project. And this is a rendering of one of the buildings, just to give you an example, and this is actually the building under construction right now. And it's been interesting to then use that technology to then be able to communicate during the design process when language becomes an obstacle to resolving conflict and being able to use that model to show it. The last project I wanted to leave you with is one that's a little bit closer to home, and this is the Columbia University Medical Center building that we're doing in collaboration with Diller Scofidio. It's a 14-story medical education building. And the nice thing about BIM on this one is that the BIM model is resident on a server accessed by multiple parties, by all the collaborators, and they're able to access it whether they're at home or whether they're at the office. And it's allowing people to work against sometimes some significant obstacles such as Hurricane Sandy and not lose a step in the process. The beauty of this one is the integration of all trades into that model. And I thought this was a good diagram to show here today because it is, in a sense, pulling out structural, plumbing, mechanical, but then pulling it all together with all trades in a cohesive model that it is used not only as a communication device, but as something that can tell the story about the design and the vision of the building. And I'll leave you with this kind of one thought, which is that I've found that BIM technology for me has enabled us not only to work better and faster and in a more cohesive way, but it's also allowed us to tell the story of design in a much cleaner way to our clients so that the idea and the vision of a building resonates at a much higher level than it had before.
Energy modeling is really used through various stages of a design process, mainly to inform building design decisions such as the building massing or optimizing a facade, sizing our mechanical systems, and understanding performance. They're also used to demonstrate code compliance or achieve LEED certifications. They're also used in existing buildings to perform audits, understanding how to prioritize energy efficiencies, improvements, or estimate returns on investments, or detect issues in operation. So this is typically an isolated analysis process that happens. And now most of our projects are using BIM in some capacity. So the real goal is to get these two to talk to each other. Our aims are really to manage and share the data, increase our efficiency, and improve our modeling accuracy when we're doing this energy analysis. So a little bit about how this has changed our workflow. So conventionally, what we would do is take building documentation, usually in 2D or drawings. We would do the manual, tedious work of doing takeoffs of areas, perimeters, understanding our load assumptions, and documenting this all by hand or manually in spreadsheets. Again, manually taking this information and inputting it into energy modeling software, and then running our analysis and then communicating those results. So now with BIM, what we're able to do is store geometry with embedded data about our load or energy assumptions within our BIM platform or our BIM application. Then we take that, and through certain file transfer mechanisms, we can take that and go directly into our analysis software, perform our energy analysis, and then bring it back into our BIM platform. So you'll see there's a few workarounds we have to do to actually achieve this. It's not perfect, but we're getting there. I'll use a case study to kind of show how we've implemented this on one of our many projects that are now using this as standard practice across our firm. So this is a project right here in New York, in Brooklyn, Atlantic Yards, which will be about a 32-story high-rise residential building and the tallest modular building in the world when built. So this was an example of not being limited by project schedule. On this project, our 3D MEP work actually preceded the 3D architecture work. So we were able to virtually construct our mechanical zoning diagrams just using the architecture 2D backgrounds. So just to understand a little bit about how this process works, we manage our energy assumptions within what's called spaces within our model. So these spaces are 3D objects. They're defined by bounding elements such as walls, ceilings, floors, or space separators. They're similar to a room with a few differences. They hold engineering data. So in addition to geometry, includes things like lighting loads, occupancy loads, equipment loads, ventilation, airflows, our schedules of operation. And really, they have unlimited data. That data is not always translated into software directly. Currently, we're trying to capitalize on the ones that are, though, currently, and just store the rest of them so that everything is done in an organized way. So what are the benefits we're seeing about integrating BIM into the energy modeling process? Automation, accuracy, checking, organization of data, visualizing the data. It's time saving. And we're now seeing enhanced data sharing within our project team and with our clients. So in summary, we've actually successfully implemented this on many projects firm-wide. We're using it for managing our energy model data, which is improving our organization and our information sharing. It's leading to more efficient and accurate energy modeling workflow. But we're doing this by actually tailoring the process to our projects based upon availability of the BIM model, the size and complexity of the project, and the analysis software that we're using. But the most important thing, I believe, is that it's enabling us to adapt to future changes in technology, software, and processes.
I wanted first to start with actually example of the threats in risk management that the facility owners have and how BIM can actually help
Dallas
with
County
that.
prisoner is on the run tonight. Police say this man, Juan Ramirez, escaped from a work detail that was cleaning up flood damage at the Dallas courthouse.
Apparently, in the middle of the chaos, he just walked off. Meanwhile, the Crowley Courthouse in downtown Dallas will be closed for business tomorrow. CW33's Giselle Phelps is live to explain what happened. Giselle.
Yeah, Walt, that's right. The Crowley Courthouse behind me will be closed for business tomorrow. It all started with a water main break early in the morning, and that led to an interesting scene that unfolded. And now the Dallas County Sheriff's Office is searching for an inmate who escaped, while officials work to get the building behind me back in working order. These are pictures of a wet mess on the first floor of the Crowley Courthouse in Dallas today.
There was a pipe burst, and it burst in an area that it hit a lot of the panels.
The flooding forced officials to evacuate the entire building and put it on lockdown.
So I think that it cost them more than the whole design that they paid for that small courthouse. So how BEAM can help actually with that? So I'll show you an example using the Ecodomus software of finding
emergency service response is of critical importance to hospital facility.
Finding the shut-off valves and finding the necessary equipment and preventing these things from happening. This is actually navigating within the facility. We find the sprinklers related to a specific room. We can navigate to a system that manages that fire protection sprinklers. Or we can just go and search for valves related to that zone. So we find a couple of valves. One of them is related to plumbing, one is related to fire protection. So we choose to click on fire protection. It shows us in real time where that valve is located. We see that it's actually in the corridor slightly above the duct. Somebody, by the way, commented that it's an ugly design because the valve is leaning in the way that you cannot get to it. So that's related to the case studies of how we properly design for maintenance. So that's one of the examples of how we can quickly find it.
The legal issues should not be an impediment to accomplishing what you want to accomplish. And bottom line with BIM, as it is with integrated project delivery, is increased collaboration. And the good news is for owners and everyone involved, when we go through this kind of process with BIM, we go through IPD, the risks of things going wrong are diminished substantially. And that's what's wonderful about these technological advances. But still, people always say, what if? What if something goes wrong? In our society, people love to point fingers. It happens from time to time. So what if are the questions you still have to ask. So what I wanted to do was just identify for you a series of issues that sort of tend to come up in these BIM agreements, understanding sort of the nature of what's going on here when we look at the relationships, how these relationships are evolving, how input into product comes into play. And a couple issues that I'll go into. Copyright is one of the key ones. You just think about it, you're now in this collaborative environment, everyone is working together, you have a BIM model in front of you. People are now inputting ideas that get incorporated into this BIM model. Who owns those ideas? We had a litigation on a big project out in Las Vegas where a construction manager representative was sitting with the engineer, and you had a meeting, and suggested ideas which were incorporated into the design, and they sued, and the construction manager rep, after he had left the CM firm, sued the engineer, claiming he owned that copyright. Well, in a BIM environment, he lost, but that's okay. But in the BIM environment, it becomes much more complicated when we're looking at things like copyright issues, when it's not done like in Bureau Happold, when you're doing it in your office, sending it to the steel fabricator, it's pretty straightforward. But if it's now in this real collaborative environment, which is what we're evolving into, things change. It just becomes complicated. But again, the law should not be an impediment. It just requires a little bit of different thinking in your approach to BIM. So just some of the issues that you should be mindful of, and these will be available if anyone wants the slides. I'm sure you might have seen this already. So here, this was some of the language. There are standard form agreements out there. The AIA has its forms, the EJCDC has its forms, Consensus Docs has its forms. They have different varieties, but even when you look at copyright, the idea is everyone owns what they produce. You put it in, it's yours. But again, things get more complicated as you get into the evolution of BIM and everyone is involved because you have this intellectual property stew. That's one of the bigger issues that I see. The other one that's really interesting to me is licensing. And every state, New York, Florida, have these licensing requirements that really to perform architecture or engineering, you must be licensed. So now you're signing and sealing a product. As these get converted, and the reason I asked the question for Gensler was when you take something and you turn it into a 2D sheet, it's easy. You stamp it, you seal it, not a problem. But as we evolve into a 3D model over time, and architects and engineers are required to take responsibility for that model. And a building department, and the commissioner indicated, they're going that way. You have a very progressive commissioner. We have a very progressive chief in the fire department. You have people going this way where over years they're going to accept this model. So we have to be careful. If you're a licensed design professional, you need to be careful that anything you're signing and sealing and taking responsibility for, you must have reviewed and confirmed. If there's a segment, if there's, let's say, an engineer for a steel fabricator, the technology has to allow that to be segregated so it's clear who's taking responsibility for different pieces of that model. Because, again, if you don't, it's not good. Assisting in unlicensed practice of a profession is a very serious crime. No one wants to commit it. No one wants to commit it inadvertently. So those are two of the more intriguing issues. And I just put up this statute for you in New York, but there are like-minded statutes around the country. In Florida is the same. You can't delegate the authority to someone else. So ultimately, you as a licensed design professional, if that's what you are, will need to take responsibility for the signing and sealing of that work product.
Once again, thank you all for your invaluable participation, which truly helped to enrich our conference today. And to all, I bid you have a wonderful day. Good afternoon.